Today we're going to do some algebra review on simplifying radicals, as this is an algebra skill that we are going to be working with in the next few lessons that we have. So when we are simplifying a radical, it says when simplifying radicals, we are looking to get the radicand, which is the term under or inside the radical sign, to have no perfect square factors other than 1. So this is one of the reasons why we want you to know your perfect squares. Because if you know your perfect squares, it makes simplifying radicals very easy. There are two different ways that we can simplify radicals. You were shown both of these ways in algebra. I will show both of them again. So you decide what is easiest for you, and it could be that you use both of them depending upon the particular number that we have. So one of the methods is using factors. So when you use factors, you don't need to know your perfect squares. We're just looking for any factors that multiplied give us that number. So what we do is we use a factor tree. So, whoops. Right. Factors of 24. I heard 12 and 2. Factors of 12.
8 and 3. That's 6 and 2.
I heard 3 and 4. Factors of 3. Okay, nothing except 1, which doesn't do us any good. Factors of 4. 2 and 2. Factors of 2. Nothing. Okay. So what I have now is the square root of, I've got 3 factors of 2 and 1 factor of 3. To simplify, we need to have a pair, and when the pair comes out, it comes out as 1. So I have 1 pair of 2's. Inside, I still have the 2 times 3 that I multiply back together to get 6. So 2 square root of 6 is the simplified version of the square root of 24. Because inside the radical, 6 cannot be simplified any further. Okay, I just get 2 and 3, not a pair to come out. What about 75? 25 and 3. Factors of 25. 5 and 5. Factors of 5. Factors of 3. None. So I'm done factoring. So I have a 3 and 2 factors of 5. So if I have a pair, it comes out as 1. And then I have that square root of 3 that's left inside. So that's using factors, doing that factor tree, looking for pairs. So 1 comes out. The other option is to use perfect squares. When you're using perfect squares, you want to try to find the largest perfect square factor and then simplify. If you're not using the largest perfect square, you can still do it, but you'll have to go another step again. And sometimes people just use it one time and then they want to stop. So key there is looking for your largest perfect square factor. So we're looking for a perfect square that goes into 24. What's a perfect square that goes into 24? 4. Is there anything bigger?
No.
No, there is not. So the square root of 24 is the same thing as square root of 4 times square root of 6. Okay, 4 times 6 gives me 24. I know the square root of 4 is 2. Square root of 6, can that be simplified any further?
Yeah, 3, 2.
Okay, but am I going to have a pair to come out? No, there's no perfect square that'll go into 6. So 2 square root of 6 is my answer. Okay. Same thing as I got when I did the factor tree. Okay. But I didn't have to do all of that factoring. Square root of 75. What's a perfect square that goes into 75? 25. 8's not a perfect square, and 8 doesn't go into 75. Square root of 25 times square root of 3. We know the square root of 25 is 5. Is there a perfect square that goes into 3? No. So 5 square root of 3 is the solution. So again, when you are simplifying radicals, you have 2 different options. You can do the factor tree, or you can look for those perfect square factors. And again, you might use a combination. Okay? When I simplify radicals, most of the time I use perfect squares. If it's a number where I'm really struggling, having to think of a perfect square that goes into it, then instead of taking that time to mentally check a bunch of numbers, I'll just do the factor tree. Okay? So depends on the size of the number when you get to some of the bigger numbers. Okay? It's hard to know maybe if 64 goes into that number. So then I just go to the factor tree because I know eventually I'll get the answer. But again, completely up to you which method you use.